Parker Hannifin, a leading manufacturer of motion and control components and systems, presents the latest in hydraulic pump technology. The Hydraulic Controls Division, a German subsidiary of the Parker Hannifin Corporation, presents the PV Plus, the better pump. It is a redesign of the proven PV series, a robust and powerful pump used today in many industrial and mobile applications. During the development of the PV Plus, many new concepts were used. The development goals were to reduce the overall pump sound levels and improve on an already strong performing PV pump. These targets were accomplished by putting Parker's design experts in close contact with universities and research institutes. This highly motivated development team drew on team experience and the latest in design tools, including the use of ProEngineer to satisfy the project requirements. So what does this new state-of-the-art PV Plus look like? First, let us disassemble the pump and see what's inside. Please note the ease of pump disassembly. After removing the servo piston cover and the displacement adjustment screw, we can remove the servo piston, which provides access to the feedback sleeve. The feedback sleeve will be reviewed later. Next, we remove the pilot cover and shaft. In this disassembly, we have not touched any of the core rotating group components, yet we have access to important wear components. This ease of access demonstrates the service-friendly nature of the PV Plus. After removing the 4 body screws, which are available in both metric or UNC sizes, we get to the heart of the pump. Removal of the pump case provides access to the rotating group, including the swash plate, the cylinder block, the pistons and slippers, and the valve plate. In addition, we find the integrated air bleed valve, which shortens the startup of a new system and ensures quick priming, quieter system operation, and improved system reliability. Finally, we take out the spring cover with the bias spring. The Parker engineers are especially proud of their achievements in noise reduction. Piston pumps like the PV Plus have to deal with 2 major concerns: pulsations occurring as a result of odd number piston variations, and a flow that is non-continuous and smooth resulting from pumping, piston compression, and decompression rates. Shown are the 9 pistons that move over the valve plate. If you take a close look, you will see that the number of pistons under pressure varies between 4 and 5 pistons. That variation creates pulsating forces in the pump. Each one of the 9 pistons shown here creates a force of 8,000 Newton at 350 bar. When changing from 4 to 5 pistons under pressure, the force steps from 3.2 tons to 4 tons. These forces severely stress the pump housing. Therefore, one of the major priorities for the PV Plus was body stiffness. A stiff pump case vibrates less under the internal forces and causes less vibration of the surrounding air. That means less excitation of our eardrum. The pump is quieter. The tools internal to ProEngineer were used to visualize the behavior of the pump body and helped to streamline the design phase. The second handicap of a positive displacement pump is the pulsating flow it delivers. The major portion of this pulsation is not caused by the kinematics of the piston movement. More than 3/4 of the measurable pulsation are caused by the compression phase. If a piston comes from the inlet and enters the outlet chamber, the fluid content first has to be compressed. A small amount of fluid returns from the outlet into this piston. This happens in 1/1000th of a second. For this short time, the outlet misses up to 25% of the nominal flow. These short drops in output flow again cause major excitation of all downstream components. The design engineers at Parker have now built a pre-compression chamber into the PV Plus, to compress the fluid in the low-pressure piston. That causes no direct reaction on the pump outlet. The precompression chamber is refilled again from the connected hydraulic system, but that happens in 2.5 times longer time. The flow drops now only 10% of nominal flow, and the whole hydraulic system gets quieter. The location and size of this precompression chamber can be seen here in the transparent end cover. Another improvement in the PV Plus is shown here. The slipper retainer mechanism has no spring. Slippers are kept down only with a fixed clearance. That improves the efficiency and is easier to assemble. This design can take higher loads, and the pump can better withstand cold start and case pressure peaks. The assembly can be performed as easily as the disassembly. No special tools or special assembly fixtures, only cleanliness and care are required. And because the whole PV Plus is built in a modular design principle, Parker can offer unbeaten short lead times. Any of the 100,000 variations and options of the PV Plus can be built and shipped within 5 working days. Now we want to look at some of the new control features. The port plug on top of the pump can be removed with ease, and an inductive position transducer can be inserted into the port. The transducer senses the position of the feedback sleeve noted earlier during the pump disassembly process. The position signal of the transducer indicates the displacement of the pump and provides the foundation to build electro-hydraulic pump controls. The PV Plus offers a wide range of electro-hydraulic controls, from the simple displacement control up to the more sophisticated closed-loop PEQ control. If the LVDT is replaced by the horsepower pilot cartridge and the tapered sleeve by a contoured sleeve, we get a horsepower compensator. Here the function of the horsepower compensator is explained. The diagram shows the PQ characteristic and the actual point of operation. Increasing pressure in the system caused by an increasing load moves the point to the right. If the pressure setting of the pilot cartridge is reached, the pump starts to compensate. That moves the contour sleeve to the right, and the valve seat is moved up according to the contour of the sleeve. Because that compresses the valve spring, the compensating pressure is raised and the pump operates along the shown curve of constant input power. When reaching the allowable maximum pressure given by the cylindrical part of the contour sleeve, the pressure does not grow further, and horsepower compensation turns into pressure compensation. Here we see PV Plus in the middle of parts from its building block set. A second pump, 2 through-drive adapters, and 3 couplings are representing its through-drive capabilities. 3 more shaft variations and a metric or an SAE mounting interface illustrate the mounting interface options. For clockwise and counterclockwise rotation, Parker offers different housings and a different valve plate. Not displayed are the 3 seal materials and the 4 port options. On the right of the pump, we see 5 of the 10 compensator versions, the contour sleeves, the position transducer, and the horsepower pilot cartridge. You see, the modular concept of the PV Plus offers a suitable version for any market requirement. Surely also one for you. The high-pressure axial piston pump presented here is offered in 5 frame sizes. The whole family covers displacements from 16 to 270 cubic centimeters, or 1 to 16 cubic inches. All 5 sizes are designed based on the same principle and offer the same features as the one described here. No matter if you need 20 liters a minute for a clamping function or 400 liters a minute for a press, the PV Plus offers highest reliability, long life, and a continuous pressure of 350 bar. And all this at a remarkably low noise level. It offers a large variety of features and options, and everything is available within 5 working days. Test PV Plus, test Parker, and the Hydraulic Controls Division. And remember, Parker not only makes pumps. Everything you need for your whole system is offered by the Parker Hannifin Corporation and its subsidiaries around the world.